Alright, so this is section 2.1, relations and functions in Algebra 2. So what I gathered is the most important part is the functions. The first one is one-to-one. It deals with domain and range. As you can see, domain, we can have whatever we have in there. One-to-one means that there's one number in domain that matches up to one number in the range. Only one, or one, they correspond to each other. So that is, I can't have, for instance, 3 go to C and A. That won't work. So it's only 1-to-1. Right? The other one is onto, and that is where every value of the range has a unique value of the domain. Now this one is different. So yeah, 1, 2, 3, 4, they can match up. 1 goes to D, 2 goes to B, 3 and 4 both go to C. That is possible to have that with our functions. So we could have two values equal the same output. Okay. And the last one is both, where they just match up straight across. Okay, so that one's pretty unique. Usually this is the case that you find with most functions. One of the other concepts is a discrete relation and a continuous relation. Discrete relation means there's gaps in between it. So we have gaps in between their dots. You see, like, they're not connected. Continuous is like a line, so there's no gaps in it. That's the easiest way to remember. There's no gaps in continuous. In discrete, there is gaps. And one of the other points is the vertical line test. That is, if you could draw a vertical, if you have a function like this problem, you can draw a line straight through it. It only goes through once, then it is a function. If you draw like this parabola on the side, if I draw a line straight up and down, straight up and down, goes through it twice, then it's no longer a function. I think that's what the important notes are from this section. There's another concept that I didn't get. It's called function notation, but when I do an example of function notation, I'll go over what that is during that time. So let me erase this, and we'll get some examples going. All right, so here's 3 examples that we're going to work out. For number 1, so state the domain range of each relation. Then determine whether each relation is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. So look at this one. It says domain, so what we're going to write is domain, right, is going to be this value. So we're going to say -2, 5, and 6, increasing order. And we're going to say range, -8, 1, and 3. Okay, so that's our domain and range for that. And the deal is, we can see each value goes to one term, so it is a function. And the question is a one-to-one, onto, both, or neither? And for this one, it is both, because each one of these values goes to one of these, and each one of these values connects to those, so both. That's it for this one. So now if we do number 3, we're going to do the same thing. What's our domain? And that's usually our x value, so domain, D, -2, 1, 4, and 8. Our range, we have -4, -2, and -6. Or no, sorry, just 6, not -6. So that's what we get for there. This one, if we look at it, it is a function. Each one of these corresponds to its own number, so it is a function. But it's not one-to-one, because, or sorry, is it one? It's not one-to-one, because this domain, we see we have 2 different domains, and we go to 2 different, or the same term. So this one is going to be onto, where we have 2 variables in our domain. They go to the same output. It's still a function. It's just not one-to-one, and it's not both. Okay. So our last example. Domain listed our x values again, so point, so it's -0.3, 0.4, and then 1.2. Our range, -6, -3, -1, and 4. This one is not a function, and the reason why it's not a function, and the reason why is because right here. I have two values of my domain, 1.2, twice, and they equal two different values. So if I were to draw a vertical line, it would go through it twice. So this one's not a function based off that. That's basically function, domain, range. Pretty easy guide. So I'm going to go ahead and erase this, and then we'll start in function notation, which is something I need to add. All right, so real quick, this is function notation from still 2.1. What we have, and I didn't realize that they teach this early, which is really good because in my pre-calc, students struggle with it. But it's f of x equals 5x minus 1. So here's our whole function. It's kind of the same thing as y equals 5x minus 1. We plug in a value for x, and we get an output. That's what f of x stands for. So it's f of x, so it's not being multiplied. It's pretty basic and simple. All you're really doing is whatever's in this parentheses right here, you're going to plug into those values of your equation. So let's work out an example real quick, and I'll show you. If, say, our f of x is 3x plus 2, we want to find f at -5. So what we're going to do, we're going to take our equation, and we're going to say, well, f of -5, that's equal to 3, -5, plus 2. That's, I'm plugging -5 in for all the x's into my equation, and we solve it out. So this is going to equal -15 plus 2, which equals -13. And that's function notation. It's actually very simple. All you do is just plug in a value in and get a value out. And that should do it for 2.1. Functions, just lots of practice doing it. Okay.